Hello viewers, so we have this question that says for the reaction sulfur dioxide added to oxygen giving us sulfur trioxide, Kp is equal to 10 at 700 Kelvin. Calculate Kc for the same reaction. Now, for us to find our Kc, we need to use the relationship between Kp and Kc. But before we do that, let's write our balanced chemical equation. So our balanced chemical equation for this will be, this is sulfur dioxide. So we have sulfur dioxide there added to oxygen. That is giving us, on the other side, we have sulfur trioxide. All right. So our balanced chemical reaction will be just putting a 2 there and a 2 on the other side. You see that we will have the same number of oxygen atoms. We have 2 by 2 giving us 4 plus 2, this is 6. 2 multiplied by 3 is 6. Sulfur we have 2 and sulfur we have 2. So it means our chemical reaction is balanced. All right, so let's go ahead and do our mathematics. The relationship that connects Kp to Kc is that Kp is equal to Kc multiplied by Rt given to the power of change in N, where R is the ideal gas constant, T is temperature, and change in N is basically the difference between the coefficients of the products and the reactants. So to find our change in N, we always use a balanced chemical reaction. For example, this one that we have here on the product side, we have our balancing value to be 2. Only, we don't have any product here. We have a single product, so we only have one balancing coefficient. On the left-hand side, here we have a 1. It's on that when the coefficient is 1, we don't need to write it. So we have a 1 here and we have a 2 there. This implies to say on the right-hand side, we have a 2, and on the left-hand side, we have a 3. 2 added to 1 is 3. So to get our change in N, we're going to say 2 minus 3. We said it's the difference between the balancing coefficient of the products and that of the reactants. So we're going to say we have 2 minus 3 giving us a minus 1. So this minus 1 is the change in N. This here, the change in N, delta N, is basically found by subtracting the coefficient, the sum of the coefficients of the reactants from the sum of the coefficients of the products. So the product side, we only have 2. On the reactant side, we have 3. So we have a minus 1 is change in N. So we have that now. It means we can go ahead and do our solving. Replacing with the values we have, our Kc, making it the subject, will be equal to Kp. Kp divided by Rt, change in N. What is happening here is we are making Kc the subject, since this is what we are looking for. So making Kc the subject, we are going to divide by Rt, change in N. So when you do that, our Kc will be equal to Kp divided by Rt, change in N, which is what we have here. All right, so let's proceed. Replacing with what we have, this will be equal to, this is equal to, our Kp is given as 10, and down here, our R is 0.0821. I hope you know this value already. This is in the units of liters, atm. Then we have more per Kelvin on the other side there. And this will multiply by temperature in Kelvin. So our temperature in Kelvin is 700 that we are given. So if you are not given temperature in Kelvin, you are supposed to change it to Kelvins. So the temperature we use here must be in Kelvin when you're using this formula. So now we have replaced with our values. All we have to do is just calculate. We say 10 divided by what we're going to find there. And when you punch your calculators, according to my calculator here, what I find when I divide 10 by this product of RT to minus 1, this is giving me a value that is 574.7. So this implies to say my KC is equal to 574.7. Yes, so there we have it. Our KC value is basically 574.7. So what we just need to know here much is how to find the change in N, and also just the relationship between KP and KC, the formula that we need to use. So this is the formula that we need to use for the relationship of KP and KC. So that's it for this video.